Good morning, class. How are you feeling today? That's good to hear. Let's all stand and let us pray first. Amen. Now I will be checking your attendance. Say present if your name is called. All right. It seems like all are present today. Clap your hands. Do we have an assignment, class? If none, let's proceed. Please read the classroom norms. All right, thank you. For our energizer, let's sing the song Twinkle Twinkle Little Star. I believe that you are familiar with this song. Twinkle Twinkle Little Star. Ready, sing. Twinkle, twinkle, little star, how I wonder what you are. Up above the world so high, like a diamond in the sky. Okay, once again. Twinkle, twinkle, little star, how I wonder what you are. Up above the world so high, like a diamond in the sky. Twinkle, twinkle, little star, how I wonder what you are. Up above the world so high, like a diamond in the sky. All right, class, you were a great singer. Clap your hands. And now let's do a short recap about the lesson being discussed last meeting. Let's put a twist in choosing who will give a recap. When I say sit, you stand. When I say stand, you sit. Whoever will fail will be the one to give a recap. Is that clear? All right. Very good. Now let's proceed. Class, do you want to have some fun? Okay, let's play the game called Desert Island. Are you familiar with this game, class? Alright, for this game, let's say I am going to explore the universe and I want someone to be with me. Now, if you want to join me, you must bring one thing with you, anything. Note, class, that this game has a pattern. If you catch the pattern, then I'll bring you to explore the universe. If not, you cannot join with me. Are we clear, class? Okay, now let's start. Me first. Um, I will bring cell phone. You cannot join. Unfortunately, you cannot join. Yes, you can join. Of course, you can join. Yes, you can join. The pattern there is when you say before the thing you want to bring is the key I am looking for so that you can pass the game and can join me to explore the universe. Now, based on the game we played, you have now the idea what will be our topic for today. Okay? Very well said. Today, we will discuss about the characteristics of stars. Before anything else, please read our objectives for this lesson. Our lesson for today is all about the characteristics of stars. Let us define first what is stars. Please read in unison. What is thermonuclear reaction? Thermonuclear is reaction. It is a fusion of two light atomic nuclei into a single heavier nucleus by a collision of the two interacting particles at extremely high temperatures, with the sequent release of a relatively large amount of energy, and that where fusion happens. When we say fusion, It occurs when two atoms slam together to form a heavier atom, like when two hydrogen atoms fuse to form one helium atom. Now, let's talk about life cycle of stars. All stars begins life in the same way, a cloud of dust and gas, also known as a nebula. Okay, now what is stellar nebula? Stellar nebula is a star forms from massive cloud of gas and dust in space, also known as a nebula. Correct. Nebulae are mostly composed of what? Hydrogen. Very good. Next we have average star. Average stars are also known as intermediate mass stars. These stars have a lifetime between 5 million and 20 billion years. Wow, that was long. These stars generate energy from the fusion of hydrogen to helium, then helium to carbon. Very good. Next, we have a red giant star. Does anyone of you have an idea what is red giant star? Uh-huh. Okay. Thank you for sharing your idea. Now, when all the hydrogen has been used up in the fusion process, the large nuclei begin to form, and the star may expand to become the red giant. Planetary nebula is a region of cosmic gas and dust formed from the cast of outer layers of a dying star. Despite their name, planetary nebulae have nothing to do with planets. White dwarf. When all the nuclear reaction are over, a small star like the Sun may begin to contract under the pull of gravity. In this instance, the star becomes a white dwarf which fades and changes color as it cools. Massive star. In a massive star, hydrogen fusion in the core is followed by several other fusion reactions involving heavier elements just before it exhausts all sources of energy. A massive star has an iron core surrounded by shells of silicon, sulfur, oxygen, neon, carbon, helium, and hydrogen. Red supergiant star. This star is the biggest star in the universe. This thought to be VY Canis Majoris, measuring about 1,800 times than the size of the Sun. Supernova is a larger star with more mass will go on making nuclear reactions, getting hotter and expanding until it explodes as a supernova. An exploding supernova throws hot gas into space. Neutron star or black hole. This depending on the mass at the start of its life. A supernova will leave behind either a neutron star or a black hole. From the image presented, what do you observe? Thank you, very well said. Example of stars, from smallest to largest. This is a life cycle of a high mass star. I need a volunteer to read. What is protostars? Thank you. Protostar is the first or the beginning process of making stars. This gathers a mass from its parents from the molecular cloud. The main sequence stars are massive stars. There are different types of star. the variable stars, binaries, and nova. A variable star is a star whose brightness as seen from Earth changes with time. There are two different categories of variable stars. The instinct variables. These are stars whose luminosity physically changes due to pulsations, eruptions, or through swelling and shrinking. The second one is the instinct variable stars. These are the stars that changes their brightness because of being eclipses by stellar rotation or by another star or planet. The intrinsic variables, these are stars which vary their light output since their brightness by some changes within the star itself. The intrinsic variables are stars that change in brightness because of being eclipsed by stellar rotation or by another star or planet. What have you noticed in the image? Okay, very good. Now please read this one. Okay, now who can give an idea about the binary star? Okay, very good, very well said. That is the exact explanation of what is binary stars. Now, a nova is an explosion from the surface of a white dwarf star in a binary star system. A nova occurs when the white dwarf, which is the dense core of a once normal star, steals gas from its nearby companion star. When enough gas builds up on the surface of the white dwarf, it triggers an explosion. Characteristics of stars. The Sun is an average star. It is not so hot or cold. It's not large nor small. The Sun is just an average star. We can compare stars by color, temperature, size, and brightness. How? Thank you for your wonderful idea. Let's find out. Color. Star range in color from red, yellow to blue. The temperature. Star range in temperature from 2000 degrees Celsius, 5000 degrees Celsius until to 50,000 degrees Celsius. Meaning to say, the hottest star are those blue in colors. So I have here some examples. Those blue, white and yellow, orange and red are the range of color of stars. Now the temperature of the stars, as you can see, it starts from 12,000. Rigel and Spica are white in color and their temperature ranges from 12,000 degrees Celsius. Now Vega is white in color and it has 11,000 degrees Celsius. The Sirius has a white color and 10,500 degrees Celsius. Now the Capella has yellow color and have 6,000 degrees Celsius. Now the Sun has a yellow color and has the temperature of 6,000 degrees Celsius. The Arcturus is orange in color and has 4,200 degrees Celsius. The Antares is red in color and 3,000 degrees Celsius in temperature. The Betelgeuse is red in color and the temperature is 2,200 degrees Celsius. Light years. Now when we say light years, it is the distance traveled by light at the speed of 300 1,000 km per second for a period of 1 year. Light travel about 9 trillion km in 1 year. So I have some examples here. Sirius has 8.5 distance from Earth in light years. Now the Vega has 26.5 distance from Earth in light years. And the Antares has 390 distance from Earth in light years. The
Betelgeuse.
has 587 distance from Earth in light years. Now the Polaris has 680 distance from Earth in light years, and the Rigel has 900 distance from Earth in light years. Compare the size of the star you see at night to the sun. Isn't the sun much bigger than any of them? Why do you say so? Uh-huh. Good point. Now let's find out. The brightness of star. The brightness is related to the distance from Earth and the age of the star, classifying stars by their brightness. First, we have magnitude stars are the brightest. Second, the magnitude stars are the weakest. The magnitude of star measures according to its brightness. Now we have the two types of magnitude. First, we have apparent magnitude, meaning to say, it refers to the brightness of a star as it appears on us. So we see the stars using our naked eye. Now the second one is we have absolute magnitude. This aims to understand the actual brightness given off by at a distance or at a standard distance. Stars seems to twinkle. Do you see them twinkle? Why do you think it twinkled? Uh-huh. Yes, good point. Another one. Another good point. You have point there. Very good. The star or stars twinkled because of light from distant stars travel through various layers of the atmosphere with different densities. Now densities, it is a substance's mass per unit of volume. These layers closest to the Earth are denser than those in the upper layers because they contain dust and other particles. When the light travels through a medium with varying densities, it bends. That is why stars are seems to twinkle as we see it as in the night. Now let's have an activity. I call this activity as which country I belong. Now we will be having an activity so that you can understand better our lesson. I have here 4 countries. Each country represents the group where you belong. Okay, count from 1 to 4. Please go to your group mates and form a circle. In 5, 4, 3, 2, 1. I have prepared a papers. This will serve as your answer sheet. In front of this paper, write your answers. At the back, write what country are you and list of the member. What you are going to do is to label the process of the life cycle of the stars. Okay, now participation of all members are required. I will give you only 5 minutes to answer the activity. The timer starts now. Time is up. Stop writing and pass your paper. Now let's do an analysis. I will ask 5 students to share to the class what they have understood from the lesson or give us his or her major takeaway. Okay, thank you for sharing your wonderful ideas. It seems like you really understood our topic today. With the same group, answer these following questions. Can you now identify different stars? What have you realized after you have discovered the characteristic of stars? How stars vary in size, color, and brightness? How is the characterization of stars related to the real life situation? Answer this one in the one half crosswise. I will only give you 10 minutes to answer these questions. Your timer start now. Finished or not finished, pass your papers. A star is an astronomical object comprising a luminous spheroid of plasma held together by self-gravity. The nearest star to the Earth is the Sun. Many other stars are visible to the naked eye at night, but their immense distances from Earth make them appear as a fixed point of light. The most prominent stars have been categorized into constellations and asterisms, and many of the brightest stars have proper names. Astronomers have assembled stars catalogs that identify the known stars and provide standardized stellar designations. A star's life begins with the gravitational collapse of a gaseous nebula of material composed primarily of hydrogen, along with helium and trace amount of heavier elements. Its total mass is the main factor determining its evolution and eventual fate. A star shines for most of its active life due to the thermonuclear fusion of hydrogen into helium in its core. This process releases energy that traverses the star's interior and radiates into outer space. At the end of a star's life or lifetime, its core becomes a stellar remnant, a white dwarf, a neutral star, or if it is sufficient massive, it becomes a black hole. Okay class, that's all for today. I hope that you have learned something today. Thank you everyone. Goodbye.